Hello everybody, this is Mr. Wilmuth with lesson 4.4, derivatives of exponential and logarithmic functions. So a lot of you, when we were doing the review, forgot what exponential functions or what logarithmic functions were. Exponential functions just when I have a number raised to a power of x. And a log is how you undo that. So the a to the u power, the inverse of that would be log base a of u. So they're just inverse operations, they cancel each other out. If I were to graph both of those, if I graph e to the x in blue and natural log of x in red, you can see that they're symmetric around the line y equals x. That's how you show that they're inverses of each other graphically. But all that means is they are inverse operations. They will cancel each other out. If you take the natural log of e to the x, you'll just get x. If we do natural log of e to the x, you just get x. Now that's what you should have learned in pre-calculus. So we're not going to use that too much here in calculus. Sometimes it'll come up when we're simplifying things. But in today's lesson, I'm just going to show you how to find derivatives of e to the x, a to the x, natural log of x, and a to the log base a of u. So those formulas, the derivative of e to the x is just e to the x. If I'm going to write that with u substitution, the derivative of e to the u is e to the u times u prime. That's only for e to the x. E to the x is a special number that has the exact same slope as itself. If I pick any other number, like this formula here is for any other number, a to the u, that's if it's 2 to the x or 3 to the x or whatever to the x. It's going to be a different formula. The way we're going to find the derivative of that is a to the u times natural log of a times u prime. Natural log of x is also a special logarithm. So it has an easier to remember formula. What this is going to be is 1 over, if I had the natural log of x, it would be 1 over x. But in this case, 1 over u times u prime, which we're often going to just rewrite as u prime over u. Just because that's how I would simplify that fraction. The formula for log base a of u is going to be 1 over u times the natural log of a times du dx, or if I were to write that the same way as before, it would just be u prime. Actually, I'm just going to be consistent here. So times u prime. They mean the exact same thing. So these are my 4 formulas that we need to know for today. The 2 that we're going to use the most are these 2 right here. You need to have those memorized. They're pretty easy to remember. Just to remember that the derivative, go away. Just remember that the derivative of e to the u, or e to the x, is e to the x, and the derivative of natural log of x is 1 over x. And then this part here, we're just using the chain rule. So this is how those problems would actually work out. So we said the derivative of e to the x is e to the x. Well, in this case, I have e to the u. So y equals e to the u, where in this case, u is x squared minus 2. Oops. And u prime would just be 2x. So I could use the formula, or you could just remember the derivative of e to the x is e to the x. And then if I use the chain rule, I just multiply by that derivative, u prime. We get e to the x squared minus 2, and that's times 2x. The only thing you can do to simplify this is maybe rewrite it with the 2x in front, but that's really not necessary. It's just a little bit neater this way. On this problem here, the problem is at what point of the graph of the function y equals 3 to the t minus 2 does the tangent line have a slope of 21? So the most important thing here is the word slope. Slope of 21 means I need to find the derivative and set that equal to 21 because the derivative function tells me slope. So I'm just going to find the derivative of y equals 3t minus 2, which I have two parts here. I have an a to the u, and I have minus 2. The derivative of minus 2 is going to be 0, so that'll just go away. So my derivative, I'm just going to follow the formula that we had before, is going to be 3 to the t times natural log of 3 times the derivative of t. The derivative of t is just 1. And in case you forgot, this was the formula here. So we said the derivative of a to the u is a to the u times natural log of a times du dx. So all we did, rewrite 3 to the t times natural log of 3 times the derivative of t, which is just 1. So this just simplifies to 3 to the t times the natural log of 3. But the question asked, at what point on the graph, and that's going to be important too, point. At what point on the graph does the function y equals 3 to the t minus 2, does it have a slope of 21? So since this is slope, I'm going to substitute that in for y prime, since y prime finds slope. So now I just have to solve for t. Well, I'll have to solve for t, and since it wants a point, t is my independent variable, I'll have to find y as well when I'm done with that. So I have to isolate the t, so I'll divide both sides by natural log of 3. And natural log of 3 is just a number. If you were to type it in the calculator, you would get an answer. So we get 21 over natural log of 3 equals 3 to the t. Now the inverse operation of an exponential is a log. So all you have to do on both sides is log base 3. The way I teach it is we're rolling 3 logs to knock that 3 down. If I were to roll log at the 3, it would knock the t down, and that's all that's left. We do log base 3 of both sides. I'm going to just type this part in the calculator, because that'll reduce to t. Now, if you're using my calculator, the TI Inspires, it will do this for you. You can see I was practicing this lesson beforehand. You can just type in log base 3 is right here. And then we type in 3. And then I'm going to make a fraction, control divide, 21 over natural log over 3. And that's our value for t. So we're going to get 2.65567. You'll remember, for the AP test, you have to go out at least 5 decimal places, so that's what I did there. Also, let's talk about how to do it on the TI-84. The way we're going to do that here is a little bit different. As you can see here, I did the same exact problem. I did log of 21 over natural log of 3. But you can see here I did divided by log of 3. The TI-84s can't do a log base 3. So you have to use the change of base formula. All you do is you type in the log that you want to type in the calculator, and then you divide by whatever the base is. So I typed in log of 21 over natural log of 3, and then did divided by log base or log 3 because in my problem I had log base 3. That's why I divided by log of 3 at the end. That's called the change of base formula. But this problem, I'm not quite done. The problem asked for a point. It did not just ask for the value of t. So all I have to do here is find the y based on my original equation. 3 to the t minus 2. So we just type that in, y equals 3 to the, I held the answer in my calculator, so I wrote a and s there, but it was 2.6556 minus 2. If you type that in the calculator, you'll get a y value of 17.11502. So that means my final answer, the point where it has a slope of 21, is 2.65567, comma 17.11502. That's it. So to recap what we did there, we found the derivative, we substituted in 21, we then solved for t to figure out what the x value was at that time, and then we plugged that, well, it was a t value, but we plugged that in to the original function to find what the y was, and that's how I got my point. Now we're going to look at an example of a tangent through the origin. This is a tricky problem here. We have to think about what the problem is actually asking us before we can set up our problem, but it's a little bit different than what we're used to. The first thing we have to understand is what does y equals natural log of x look like? So in case you forgot, y equals natural log of x, I've already got that in here. I'm just going to graph just the red function here. So it's this curve here. It's this curve here. So I want to know what is the tangent that touches through the origin and touches this point. So I have to find out what that tangent is. The reason why this problem is so tricky is because I don't know what the x value is. I don't know what the y value is. I don't even know what the slope is. I do know that there's a point where it's tangent, though. And whatever that point is, whatever it is, I don't know. I'm just going to say that there's some value, a. And since this is the natural log function, this y value is natural log of a. So the point here, the point is something, and natural log of that same thing. Okay, we'll keep that in mind as we move forward here. I do know one other thing about this problem. I know what the slope is, because I can take the derivative of natural log of x to find out what the slope is. And now I won't exactly know what the slope is, but I'll have an idea of what it is. So the slope, y prime, is just 1 over x. And we saw that on the first page. The derivative of natural log of x is just 1 over x. So this is one way to write the slope of the entire function. If I want to know what's the slope at that point a, though, this is the point that I'm looking for. I want to know what's the slope here. It is just 1 over a, because I'm going to substitute the value of x in. In that case, I still don't know what the value of x is. I called it a, so I'm going to leave it as a. So this is the slope here. Slope is 1 over a. Another way we can find the slope, and this is why it's tricky, is we have to say, what are 2 different ways I could find the slope? Is to look at the 2 points that I have. I have 2 points. The one is, oh, this should say natural log of a. The one is a natural log of a, and the other is 0, 0, because it goes through the origin. It says that right here, it goes through the origin. So another way to find the slope is rise over run. That's going to be y2, which is natural log of a, minus 0, over x2, minus x1, a minus 0. So I have natural log of a over a. So I have two different formulas to find slope. Since the slope has to be equal at both these points, all I have to do is set the slope equal to the same thing, the slope. Well, to simplify this, all I have to do is multiply both sides by a. These a's cancel, these a's cancel. I get 1 equals the natural log of a. Now remember I said we're going to do a little bit of properties of natural log and exponentials. The way you get rid of natural log is e to both sides. E to the first power is just e. So we have natural log, a equals e. Now, that's not what the problem asked. The problem asked, what is the value of n? I can plug that into either equation. I can plug it into natural log of a over a, or 1 over a. The derivative formula looks easier. I'm just going to say m equals 1 over a is equal to e, 1 over e. And in case you forgot, e is a number. Okay, e is a number. If you type it in the calculator, come on, turn on. If you type it in the calculator, you get 2.7182. So even though it still looks like a variable, it's not. It's a number. So we can leave this. This is the answer to the question. What is the value of the slope? Example 4, we want to find the derivative using multiple options here. So the easiest way to find this derivative would be to use properties of logarithms. I told you that log a and a to a power cancel each other out. So one way to do this would be to rewrite this as log base a of a to the cosine of x. These two terms cancel, and you get cosine of x. If we want to find the derivative, boom, negative sine of x. That's the easy way. Let's show how we could do this using the chain rule, though. Let's say we wanted to not cancel first. We wanted to just use the chain rule. So that was option 1. This is the easy way. And now over here, we're going to look at the chain rule. So we're going to use the formula, which was the derivative. Let's write it like this. We're going to say d dx of log base a is a to the, is that what I have to do? Yeah, that's what I have to do. Is 1 over, log base a of u is 1 over u times natural log of a times u prime. In this case, u is a to the cosine of x. So I can find that too. I'm going to have to use my formula for the derivative of a to a power. I'm going to rewrite the formula, but instead of that, I'm going to say a to the v. So a to the v is, the derivative of a to the v is a to the v times the natural log of a times v prime. That's just my formula. I wrote it in terms of v since I have to do a double chain rule problem to do it this way. So the derivative of the outside is I'm going to use this formula here. going to be, so let's write d dx of log base a to the cosine of x. That derivative will do the derivative of the outside, so we'll have 1 times u, we'll use my inside, it's a cosine of x, times natural log of a times u prime. U prime will be this derivative here, the derivative of a to the u. So that is going to be this right here. It will be times a to the v. In this case, v is cosine of x, times natural log of a, times v prime. The derivative of v is negative sine. Now, all of this here is on the numerator. It's all, I could just rewrite it as one big fraction. It's all in the numerator. So because of that, and everything's being multiplied, so I can cross cancel. A to the cosine of x cancels. Natural log of a cancels. I'm just left with negative sine of x over 1, which is just negative sine of x. So you're probably thinking, why do we do it the long way? It doesn't make any sense to do it that way. You're right, it doesn't. However, sometimes it's nice to see that these rules work, and all the rules work well together, whether you choose to do it with option A or by using the chain rule multiple times. Now we're going to consider the chain rule and all of its power. We're just going to look at how do we solve a problem using the chain rule if it's not a normal number. Well, the answer is just like any other problem. So this one should be pretty easy. The way you're going to take the derivative is just bring square root of 3 down because it's just a number. And then I subtract 1 from the power. That's the answer. We have a similar problem here. Oh no, I lost my pi. This is going to use the chain rule. I'm going to do the derivative of the outside. So y prime is going to be pi, because I just bring the pi down, times the inside, 1 plus sine of 2x. And we'll decrease this power by 1. But this is the chain rule. Since I didn't take the derivative of the inside yet, I have to multiply by the derivative of the inside. The derivative of sine of x is cosine of x, but this is sine of 2x, so I have to use the chain rule again. So I'm going to have the derivative of the outside, keeping the inside the same, and then multiply by the derivative of the inside. The derivative of the inside is just 2. And there's not much I can do to simplify this besides writing the 2 at the front, 2 pi instead of times 2 at the end. That's all I would really do to simplify that. Those ones are pretty easy. I think they seem kind of out of place in this section. But all it is just practicing the power rule. This problem here, we have to consider what the domain is of f of x. We want to find the domain of f prime, where f of x is natural log of x plus 1. So the way I'm going to do that is first by taking the derivative of x plus 1, or natural log of x plus 1. The derivative is the natural log of x. We just throw everything on the inside on the denominator. And then using the chain rule, I multiply by the derivative of the inside. Well, in this case, the derivative of the inside is just 1. So then multiplied by 1, we just had 1 on the numerator. Okay, so the question didn't ask what, oh, it did say find f prime, which we did. But it also says state the domain. Well, clearly we can see that x does not equal 1. Because I can't, oh sorry, x does not equal negative 1. Because I can't divide by 0. Okay, but there are some other issues here. Even though the graph of 1 over x plus 1, it only has a problem at x equals negative 1. Let's take a look at it. Let's look at the 1 over x plus 1. So the only problem with the domain here is at negative 1 because it has an asymptote. But if you remember what natural log looks like, if we look at the equation of the original function is the blue function, natural log of x plus 1. Since that doesn't exist to the left of negative 1, that means my derivative can't exist there either. So even though it looks like the only problem is that x equals negative 1, actually the domain is going to be from, and let's pull this up here. The domain is from negative 1 to infinity, and that's not including negative 1. So the domain is negative 1 to infinity, oops, and that's our domain. Now we're going to find the derivative of x to the x power, where x is greater than 0. When it's negative, it runs into some problems. So we're just going to consider the positive domain here. So the way we're going to do this is we're going to take the natural log of both sides. So I'm going to have the natural log of y. And if I take the natural log of x to the x power, I can use the properties of natural log to rewrite this. Natural log of x to the x power. Now this is something you should have learned last year in pre-calculus or maybe in algebra 2, but the properties of logarithms are that I can rewrite this as x times ln of x. So I have natural log of y equals x times the natural log of x. But you really had to think outside of the box to figure this out, because you would have had to see I need to rewrite this in terms of natural logs so that I can use the properties of natural log or any logarithms to rewrite it so I have x natural log of x. Now I can take this derivative. So on the left side here, we're going to use the chain rule with the implicit differentiation. We have 1 over y, because the derivative of natural log of x is 1 over x, times dy dx equals, now I have to use the product rule here because I have x times natural log of x. In case you're unfamiliar, this is natural log of x. It's kind of like sine of x. It's a function of something we're doing to x. So it's x times, see here it is times, x times natural log of x. So I'm going to have to use the product rule. Let's go over here, say u is x, and du is 1, v is ln of x, and dv is 1 over x. Okay, so when I use the product rule, I'll get x times 1 over x. Now if I were consistent, I would multiply by the derivative of x here, but the derivative of x is dx dx, which is 1. So it's the product rule. Now we're going to do 1 times ln of x. So x times 1 over x is going to simplify to 1. 1 plus natural log of x. And that is 1 over y times dy dx on this side. I want to find what the derivative with respect to y is, so I'm solving for dy dx. I'm trying to isolate dy dx right now, so I'll just multiply both sides by y. And I can rewrite that, since y is equal to x over x. If I want to write this in just terms of x, let me slide this up. The original problem said y equals x to the x power. So I can rewrite this as dy dx equals x to the x power times the quantity 1 plus natural log of x. And that's all I have to do there. You could distribute, but it's not going to help us simplify things any further, so we can just leave this problem like it is. Our last problem of the day, we're going to consider a word problem where we look at an example of how the flu spreads. So the problem here says that the flu can be modeled by this equation here, 50 over 1 plus e squared, or e to the second power minus t. And this is where p of t is the number of people who are infected after t days. This is a cumulative model, so it counts the total people infected, not the people who are currently infected. Let's just take a look at what that looks like real quick. So let's clear this out. I have 50 over 1 plus e. Where's e? To the 1 plus, or 2 minus t. All right, and let's see what that looks like. So it starts out almost at 0, and then it goes up really fast. I can't even see this really. Let's try zooming out. Okay, I can see it a little bit better here. I'm going to zoom out just a little bit further. Okay, there it's a little bit too zoomed out, but you get the idea. It goes up really fast, then it levels off. The reason why that happens, and this happens with any model like this, if we're looking at the spread of illness, there's only so many people in a closed environment that can be infected. So if we were looking at our school, for example, there's about 2,000 people at the school. The flu will spread really fast because everyone's contacting each other and they're giving the flu to each other very fast. It's exponential. But eventually we run out of people. Only 2,000 people can get the flu, so eventually it has to level off where either everyone gets it or people are immune to it and they can't get it anyway, but everyone that's capable of getting it does get it. So that's what our graph looks like. It's going to start out low, spike up, and then level off. The question asks, estimate the initial number of people with the flu. How fast is the flu spreading after 4 days? And when will the flu be spreading the fastest? Find this rate. So there's an important word here, initial, means the starting time. How many people had the flu at the start? So that means that t is going to equal 0. We're just going to do 50 over 1 plus e to the 2 minus 0. I don't know what that is off the top of my head, so I'm going to use my calculator. $50 divided by 1 plus e squared. I got 5.96. So we're going to say approximately 6 people. Realistically, that's the most likely answer, that it was 6 people at the start. Now we want to know how fast was the flu spreading after 4 days. If I'm asking for how fast this flu is spreading, this makes me think they're asking for a rate of change. And we all know rate of change is the derivative. That's what we've been learning about. So at some point you know you're going to have to take the derivative of this. So we have a couple options on how to do this. We could use the quotient rule. But I don't really want to use the quotient rule in this problem because I can use the power rule. I'm going to rewrite this as 50 times the quantity, 1 plus e to the 2 minus t to the negative 1. Now I could use the quotient rule, but I don't want to. I'm going to use the power rule. Or not the power rule, the chain rule. Let me just move this up so I have some more room to work with. Okay. So what I'm going to have here is, I want the derivative. I'll say p of t equals 50 times the quantity 1 plus e to the 2 minus t to the negative 1. And the reason I could do that is because on the bottom of my fraction, I can just change the power to negative 1, and then it's in the numerator. So I have the inside is going to be 1 plus e to the 2 minus t, and then inside of that will be this. So it's going to be a double chain rule. The inside of the first function will be 1 plus e to the 2 minus t, and the inside of the next function will be 2 minus t. So let's underline that here, that color, and we'll underline this in purple. So my first outside function is going to be this negative 1. I'm going to bring down the negative 1, multiply it by 50. I get negative 50 times, so this is 1 plus e to the 2 minus t. Oops. And then I'm going to lower this power by 1 to get negative 2. Okay, so we lowered the power. Now we want to multiply by the inside function, the derivative of the inside, which is e to the 2 minus t. So we're going to multiply by e. The derivative here is e to the 2 minus t. And now we have to multiply by that derivative. It's just going to be times negative 1. So all I really need to do to simplify this, negative times a negative, is going to be positive 50 times e to the 2 minus t times 1 plus e to the 2 minus t. But it actually asks for what's the rate of change after 4 days. So I'm going to plug in 4 for both values of t. So this was p prime of t, and this is p prime of t. So now I want to find p prime of 4. P prime of 4, we're just going to substitute 50 e to the 2 minus 4, 1 plus e to the 2 minus 4. We'll plug that into the calculator. So we have 50 times e to the 2 minus 4, which is just going to be negative 2, times the quantity, 1 plus e, and again it's going to be negative 2. So this says that the rate of change after, I guess I can show you here, the rate of change after 4 days was about 7.68 people per day. So the rate of change was 7.68 people per day getting the flu. So our last problem here, our last part of this problem, just says when will the flu be spreading the fastest? One way to do this would be to graph what the flu looks like and find its maximum. To find when the flu is spreading the fastest, the easiest way to do that is going to look at the graph. Going to be to look at the graph of the derivative. So let's see. Let me make sure I'm in the right place. We're going to do the math, and then numerical derivative. So we wanted to find the derivative of, with respect to x, of this function here. Whatever. So what I'm going to do is just type in that function again. 50 divided by 1 plus e to the 2 minus t, or in this case 2 minus x. And what we're going to do for x, instead of just saying find it for a specific number, it can graph it. If we say x equals x, it usually takes a little while to graph it, but let's see, that red line there is my function. It's a little hard to see. Oh, it's going slow. You can see it has a maximum right here. So I'm going to turn my blue graph off, so I don't have to see that. And I'm going to zoom in some. And then all I have to do once this graphs is I'll use the calculator to find the maximum. Let's see. Come on, go, go, go.
It moves like a turtle.
Calculate the maximum. You just click once on the left and once on the right.
Drew's a slow swimmer.
And this tells me that after 2 days, the flu will be at a rate of 2.5 people or 12.5 people per day. Those both seem reasonable numbers to me. The flu spreads fastest after 2 days. Sure. So my answer to this is, when will the flu be spreading the fastest? After 2 days. And that rate would be 12.5, 12.499, we'll call that 12.5, 12.5 people per day. So thanks again for watching.
And Drew's a slow swimmer.
And make sure to like, comment, subscribe. I know you guys like to do that stuff. And stay tuned for our next video will be after Thanksgiving break. So enjoy your break, and make sure you get that take-home test done.
Drew's a slow swimmer.